let's say, an application, it's, I guess, rather uncommon for a company to go out and look for consulting or stuff like that. It's more the base technology, which companies which are developing products based on that is very good to do this kind of work. Like the Linux kernel is, of course, used in all these product types I mentioned earlier. And this is, well, at the very core of the system. And this is the kind of open source project which, in my opinion, is very good suited to do work as a freelance developer consultant. I don't think it will work very well to do that on application development or stuff, because a lot of the application developers are either volunteers or getting paid for by some distribution, or let's say a Mozilla Foundation or the Open Office Foundation or stuff like that. But I don't think this will work very well as an external developer, because most companies probably don't need any external help in especially development. Maybe training, maybe consulting and support, but probably no development. So it's basically the base technologies, the low-level stuff, which really lends itself to doing that kind of work. And yeah, I mean, so if you're working on some base level technology, I'm going to keep with the Linux kernel because it's a good example in my opinion. So if you're doing that, the next question would be, how can you find work, how can you find somebody who would be willing to give you money for that? And if you're working, as I was telling you earlier, if you're working on such a project, since all the open source project, work is done in the open on mailing lists, the source code trees are open, and everybody who is looking for somebody who's going to start looking where the development is done and where the source code actually is. So people will notice you basically from alone, and will often find you and ask you for if you would like to do some work, and you don't even have to actively search for them. This happens more than you would expect. In many cases, you just get an email, oh, would you like to do this work, or we need help in this area, or something like that. And also, other developers you're working together with on a project, they might know somebody who needs help, but might not be able to do it themselves because they're employed or because they're busy, and they will pass it on to you. And it's really, if you're working on an active project which is used, you will get, people will come to you and ask you for help. If you're in a visible position, like doing a lot of work or doing good work, people will notice that and ask you for help. So it's not so hard to actually find work if you're doing the freelancing in that area. You're also usually the open source, since the development is happening in so many different places and there is no visible meeting between the developers. Conferences are very important. So you usually go to a lot of conferences, meet the other people working on the project, and companies doing work using that project in their products or whatever will often also send one of their employees to get to know the people, to get to know the technology or the plans for the future. And you're going to meet them there, and they will get back to you and also ask you for help. And I mean, also you can do the regular stuff, of course, having a website and advertising your service. But in many cases, I've never done that, and I've actually never needed that. In all the cases, I've been working for people that came up from alone. I was never actively searching, so it's easier than you might expect. If you're doing the work, people will come to you. So if you want to work as an open source hacker, there's of course one more thing to it. This is going to be the second part of the talk. You also need to be, of course, an open source hacker, so you need to work on open source projects actually. So the second part I will talk a bit about how to get involved with open source projects, how to get into that, what to do, what not to do, and how to find your place inside in open source projects. So I'm not sure how many of you are doing open source work actively. Okay, so quite a few. I guess, I mean, people might know how open source project is basically structured. there, of course, every project is different in some way, but they have some, usually they have some infrastructure, they have a project website, they have some openly accessible code repository where you can get the source code and where you can look at the change logs and so on. They might have bug trackers. They usually have some mailing lists where the main development happens, where developers exchange ideas, exchange patches, and well, basically where most of the interaction actually happens. They might also have some IRC channel for like talking to each other more quickly, for more quick questions, quick answers. But usually most of the work is done on mailing lists. From a structure, you usually have some project leaders which are doing the main decision making, or like making releases, doing the, or like if people have conflicts with where the project is going, making some decisions. And so you usually have some project leaders. You might have maintainers if you have large projects. You might have maintainers which are responsible for like smaller areas of the project and making the decisions in that area, like what code goes in, what doesn't go in, and how, well, the general direction. You often have more than leaders, project leaders and maintainers who have people with commit access, which have the right to apply work of other people to the main source tree. So if you're doing some work and sending them to that, it's not the project leader or the maintainers who have to look at everything and have to say it's good, it's not good. You have some other developers which usually have done a lot of work over time, which are allowed to take your patch and apply it and say this is good or not good. You have people working on bug trackers, you have people working on documentation. This is basically the people like how most open source projects are structured from a people perspective. And you have generally a very similar workflow in all open source projects. You have people sending patches, you have people reviewing patches, you have people testing patches, and you have people integrating patches. And while that happens, if you're sending your patches to the mailing list, discussion about the patches happen, if the code quality is good, if the general direction of development is good, and if people agree to what you're trying to achieve or not, and so on. And basically there's always some discussion whether people like the work, and if yes, at some point it's going to go into the source tree. You might have to, well, the workflow might involve you having to write some documentation for that stuff, having to write some test cases. In some cases you have to sign agreements copyright agreements that you hand in your copyright to the project. That's mainly the Free Software Foundation projects, or there are some which require that if companies are behind the project and companies are owning the project. They sometimes require you to do that before they will accept your patch, but it's rather rare. So this is basically how most open source projects are structured. And well, if you want to get involved in some project and start working on that, well, the first thing to do, of course, is find some project which is fitting for you, for your personal interest. I was telling you about low level and then system stuff. It's very good for doing consulting work and so on, but if it's not your area of interest, it's not going to work. You have to have something which is interesting to you personally. So you're going to spend a lot of time, you're going to work on that. The nice thing is, as a lot of you, I guess, as a student, this is a very good time to do that. In many cases, you have enough time to get involved. Your studies are going to take a couple of years, so you can get slowly involved and expand on that. And you're also going to learn a lot of valuable stuff for your studies. So as a student, this is a very good time to get involved into open source projects and coding. And well, once you have found a project which sounds interesting to you from what it's doing or from a technology point of view, well, first thing you should probably do is have a closer look at that stuff, reading the project website, reading the development documentation if there is any, reading the user documentation, looking at what people are involved in the project, how it's structured, like who might have commit access, who you should listen to, who you shouldn't listen to. If like the project leader or some maintainer is telling you what you're doing is not so good, it's something different if some random guy on the mailing list is telling you that. So it's good to know the structure of the project and the people involved. So you're usually going to find that somewhere on the website or when following the mailing list. So it's good to know the responsibilities, how they're, which person is responsible for what in the project. It's going to avoid you pissing off the wrong person, maybe might be, or just knowing how the workflow goes. You also, of course, have to know how the project is working, how the patch interaction is done, what kind of tools they use. I mean, they might have, for instance, some tools for automatic checking with your code for common mistakes or something. And it's good to know that stuff because otherwise you can easily make mistakes which are, the people will just tell you, read the website or use our tools. So it's a good idea to just get familiar with the environment you're working in, will work in advance. It's going to make it look better if you do that stuff right from the beginning. So also, there are projects differ in how patch submission goes. If you have done some work and create a patch to send the work to the project, in some cases you just send it to the mailing list and wait for some response and hope somebody will look at it. In other cases you send it to the maintainers or the project leaders or whatever, and it's good to know that stuff so you won't get, I mean, if you're supposed to send it to the maintainer, you're just going to send it to the mailing list and you won't get a response. You're going to sit there and not be too happy. So if you know that, like follow the stuff a little bit, look at what other people are doing, you're going to avoid being disappointed, and it's not hard. I mean, also some projects have different development phases. Like for instance, today we had the release of the Linux 3.7 kernel, and after that happens, usually all the new patches for the next release go in within the next 2 weeks. And after that, no features are allowed until the next release. And so some projects, especially smaller projects, might take new features and patches during the entire development phase between two releases. Other projects might have some staged phases where new stuff is just allowed at some specific time, and after that only bug fixes are allowed. And you should also just look out for that stuff a bit, so you can follow the common practices, how people are working in a specific project. It's all, I mean, if you follow the mailing list and look at what other people working on the project are doing, maybe there are also some guidelines, you probably won't do something wrong. I mean, it's not terribly bad to do something wrong, but it's not hard to avoid these mistakes from the beginning. And yeah, people will be happy if you do that, and if they notice you have become familiar with the processes and how development works, people will appreciate that, and they will be happy that you've done the effort and not, well, just dumped everything on them. So yeah, so now you decided for a project and got familiar with how the project works, and you want to start doing some hacking. So some projects have a very large code base, a lot of code, like the Linux kernel, I don't know how many millions of lines of code. So it can be quite intimidating if you have this much code, so where do I start and how do I get into that? And well, in my opinion, the best way to do that, if you have a huge code base and want to do some interesting hacking on that, start somewhere you know. You've probably been using it in some way, other way you wouldn't be interested in that. And you have some parts you know. So look at the parts you know how they work. You might even not find the code. So if you want to find where is this implemented, I know this feature, and this feature might have some text message or some error message or something like that, which you know. Just search through the entire source tree for some message you know, some function name you know, some module name you know, something like that, and start looking for something you know. Just then, very easy is to find some text strings, error messages or something. Start there, look around, why does this happen, where does this error come from, and so on. And then you have some starting point which you are already familiar with from the external perspective, and you can try understand the code moving from there on. If you do that for a couple of places, you're going to get a feeling like how it's structured, and this is, my opinion, the easiest way to get into a large code base, just looking for stuff you already know, and which you can easily find, because otherwise it might be pretty hard to even find something in tens of million lines of code. So look for stuff you know, use grep, use whatever tools you're familiar with to locate that source code, and just try to understand it. Every time you're going to look at it, you're going to understand it a bit better and understand how it's all fits together. Then if you have found some place which you know, like you have found your text message, your arrow string, make some small changes, like add some prints, which gives you some internal state, and go incrementals. Make small steps and try to understand how the code flow goes, when it's called, what it does, in what cases it does what, and so on and so on. Just make small changes until you get a better feeling for that stuff. This is my opinion of a very easy way actually to get into code which you don't know and which is very large, and you can also run it in a debugger, run backtraces, look at, if you can run it in a debugger, it's hard for the Linux kernel, but it might be in user space for applications and stuff, you can do that quite easily. And you can use a debugger, look at internal state variables and so on, and from there on just get a better understanding. So this will often take some time. I mean, if you're interested in that project, you're probably willing to spend the time. It will get easier and easier and easier over time, but it will, of course, take some time. For instance, the Linux kernel is a very, very large project. It took me at least 2 or 3 years to really get understanding of, I'm mainly doing networking work in the networking stack, and it's a very complex area of code, so it took me a couple of years to get a good understanding, but it only took me like 1 week to start doing some hacking, and I mean, it crashed a lot, and it broke, it was not the best code, but well, you learn as you go, I guess. And you just do it, and you're gonna learn. That easy, actually, basically. So also, yeah, when you want to work on code, whether it's large code or small code, you have to learn how to use the right tools for that code. There's lots of tools which can make your life easier, like, I mean, learn how to use a debugger, learn the build environments, compilers, and so on. There might be code generators which can generate code for you. There are code refactoring tools, code checking tools, some tools for doing static validation of the source code, some tools which do runtime checks while you run the program. They can give you information. You have memory leaks, you're using memory incorrectly, and so on. A very important tool is to learn how to use the revision control system where the source code is kept, so you can look at change logs, can look why a change was made, and all that stuff. There are tracing tools which can tell you what the code is doing when it's running if you don't understand it. And if you learn how to use these tools, it's going to be easier to do development, and it's going to be easier to understand what the code is actually doing or why it's doing something wrong. And so it's quite important to look at that stuff, learn what tools might be appropriate for working on a specific code base. So once you getting into that project, at some point you should start just participating in the mailing list, interact with other developers. I mean, there are many different ways how you can do that. You can just look at other people's code in patches and try to understand what they're doing. You can tell them this might be wrong, or this feature seems badly implemented or too unflexible or whatever. Try to understand what they're doing. And if you're not experienced and want to do some first coding on some project, independent of how large it is, one very good way to do that is always bug fixing. If you run into some bugs, and all software has bugs, and then you have a very specific goal to reach, and you have to understand why the bug is happening, where it is happening. It's not as hard as it might sound, and this is, in my opinion, a very, very good way to get into foreign code bases, because you have to understand a lot of the situation, the internal situation of the code, the state, and why the bug is happening. And also, if you do some bug fixing, it will be very appreciated by the project members. Bug fixing is always, people are very happy if somebody is sending good bug fixes, because everybody knows how much time it can cost. It can be a lot of time for one line of code or something very small, and people will really appreciate that, doing that for an open source project. You can also do some cleanups if the code is badly structured, or add simple features, documentation, some small improvements, help testing. These are all good ways to get more familiar with the project, get into working with that. And I mean, you're gonna find what's interesting to you personally very soon if you do that. I would really recommend bug fixing. It's not hard. Improvements like optimizations, code simplifications, and so on are also often very much appreciated. Review, people doing code review of other people's work. It's always a shortage of these people, so whatever help you're doing there will also be the people who will be very thankful to you. Testing is even less people are testing than doing code review in many cases. So if somebody else is doing some work and asking for testers, if you have some free time, what to help, just do some testing. And even if it works perfectly, tell that person, yeah, it works perfectly, I haven't found any problems, this is what I did. This will be very helpful to other people, and they will be thankful and enjoy working with you, which is important because it's supposed to be a constructive environment where people are working constructively together. So if you want to add some new features, I wouldn't recommend looking at some wish list of the project or something. You can do that, of course, but just do something you think is useful for yourself. I mean, in many cases, when you're actually using software, you have something which is missing for you. Just try to add that. It's going to be useful for you. You're going to have some good idea why you want it and how you would like it to have done. So basically, the basic idea is scratch your own itch, do what you need, and well, try to do it good. And this is also a very good way to get involved in developing on other projects. So if you want to do some work and don't know really how to implement a new feature or do some bug fixing, like you have discovered why the bug is happening, but you're not so certain how to really do the correct fix or proper fix, just ask people on the mailing list. Most people are really happy to help you if they see you have done some work and have spent time, but are not entirely sure about the environment. They will explain stuff to you, and at that point you learn something about the project, and you will learn about the code, and you will learn how to do your fix right, and in the end you can do a proper fix and push it upstream. And you can ask any question. There's also, if you're worried about not being able to speak English that good, there's projects, people working on projects are coming from all directions of the world. In many cases, the developers are not speaking English natively as well, so this is not a problem. You shouldn't worry about that. Just try, and people will understand you in most cases. I mean, if not, just try to explain somewhat differently. So I would never worry about the language barrier. I mean, I know people do, but you shouldn't. Just try it and it will work. So, and well, if you ask questions, there are a lot of questions usually on mailing lists. People are asking stupid questions, people are asking smart questions. And what people don't appreciate if you come there and ask, please explain from the beginning to the end, how does this work? People will tell you, look at it yourself and figure it out. But if you have done half the work and don't understand the specific stuff, at that point they will help you. They're just not going to do the entire work for you. But if you ask smart questions like, I'm understanding this happens like that and because of that, but I'm not exactly sure why this is happening. Can somebody explain that? And you probably shouldn't have a problem finding some help. So basically, do a bit of work for yourself. And if you at some point you're not getting any further, at that point it's not a problem to ask a question. Don't expect people to do all the work for you or spend their time explaining everything to you. And everybody's going to be happy if they see you're trying to get into that. And I mean, every project is happy to get new developers which are trying to do something useful, so if they can see that, they will help you. And it's also going to help you because you will understand better. And well, in some cases you might even ask a very smart question and did a lot of work and you will still not get any feedback. That also happens because people might be busy, and it always happens. People might just have a lot of email and have missed your email. It might happen, you can repeat a question or ask again, but always stay polite and don't be demanding, because in many cases the other people don't get money for doing that and so on. So it's basically, you're working together, but don't expect them if they won't help you, it happens. I mean, in most cases you can expect somebody to give you some help, but it might happen that they won't, and at that point stay polite, don't be too pushy, and so, yeah, at that point you're very much into the project, understand the source code, have learned to work with the people, and well, at some point you've done some work creating a patch. So at some point you should take your work and push it to the project to get it upstream, to get it back into the official source tree. This is actually the main point of doing the work, to get it released and get it out in the world. So the usual process is you take your work, you create a patch, which is the difference between the state before you did your change and the state after that, the source code differences. And you should usually just do one logical change per patch. Don't put 5 things into one patch which are different. If you need for your feature, for instance, you added a new feature, you want to change, you need some infrastructure changes, like you need some new arguments or function or whatever. Do that infrastructure change in one patch, and do another patch which implements your feature using that change. Because these are, in many cases, logically separated. And if you do that, your patches will be a lot easier to understand for the maintainers and people with commit access, and they will be easier to review, which means they will review them faster and commit them faster. And also it's easier if in 1 year or 2 years you want to understand why a change happened, and you look at the change logs and the revision history. This will make it a lot easier to understand what was going on at that time. This is in many cases hard for people who are not used to work like that, because if you're hacking on your own private source tree, people often don't care about that. They just change stuff here, all around the place, and after that, at some point, if you introduce a bug, it's very hard to figure out at what point did it happen, where did it happen. So it's, this is usually something which is not taught at universities, how to do well-structured development. Basically, make small patches, make logical changes, don't mix up too many different things in one go, and it will be very easy for people to review your change. Also very important is to write good change logs. Describe what you did, not only what you did. If you made a good patch, people are going to see what you did, but more importantly, why you did it. So if you're making infrastructure changes, like adding arguments to different function types and so on, don't say I've added that argument, it's obvious you did. Say why you added that. Say because I need it in my next patch, because I want to add this feature and this needs it available, and so on. So don't describe what you did, always describe why you did it. This is important for people to understand. And yeah, you should do some testing on your changes, so you don't break other stuff and you know your feature works and so on. Also, if you write change logs, describe how you tested your stuff, so people can reproduce it. If you're making performance improvements, give some numbers. Say, this was slow before, this is fast now, give some numbers. If you have a new feature, say, I've tested this case, this case, this case, and they all work, and so on. And this is, if you do that, you have produced a very good patch in the end, probably. And at that point, you can just take it, send it to the list, and well, at that point, wait for some answer. If you made a good patch, people might just take it, apply to the source tree, paste thank you, and be happy. They might also tell you, we don't want to do that. This is structurally wrong because you might have missed something and so on. You can, of course, always, there's often a discussion about features. You can try to convince people this is useful because it's doing something useful. They might disagree, and it's up to you to sell the patch to them if it's not about fixing something. So you have to convince them. This might take some discussion and so on, but you have to get used to that. At some point, they might say, no, we won't take it. And at that point, don't be disappointed. It happens to anybody. You might have spent a lot of time because you thought it was the right thing to do. You can expect some reasoning from the people. If they say no, you can expect them to explain to you why no. So at least you learn something for the next time, and you can do a better patch next time. So it's always going to happen at some point. But well, don't be too disappointed. Just try again, understand what the people